Okay. Good morning, students. Myself, Dr. Sunil Sarkadanavar, Assistant Professor, Department of Electronics and Communication Engineering, SG Balekundra Institute of Technology, Belagavi. Today, I am here to give a presentation on telecommunication traffic of module number 3 of digital switching systems. Let us move to the contents of today's class. Telecommunications traffic, which includes introduction, unit of traffic, congestion, traffic measurement, mathematical model, lost call systems, queuing systems. Again, the module number 3 is divided into two specific parts. One is with respect to the telecommunication traffic, and other part we are speaking about switching systems, which includes introduction, single stage networks, grading link systems, and as well as GOS of linked systems. Today in this class, I am going to cover the telecommunication traffic, which includes introduction, unit of traffic, congestion, and as well as traffic measurement. Now let us look at the introduction part. So whenever we speak about any industrial plant, if we need to design any telephonic systems or any industrial plant or any systems, so at that time an initial decision must be made as to its size in order to obtain the desired output. So whenever I am going to design any industrial plant or any telecommunication system, we need to plan for some parameters. For example, how many subscribers are needed to the services, or how many devices or how many stations we need. These are the things we need to carry out. And what about the traffic, how we are going to monitor the traffic? These has to be utilized, and these has to be monitored in order to obtain the desired output. So because based on these parameters, we are going to get the results, we are going to get the productive output of that particular module. Here in this figure, we have considered a simple telecommunication network where there are many substations and as well as the server along with the control room. These are some components there is available in any industrial plant or any telecommunication system. And these are the things like depending upon the size, how many subscribers and how the traffic is going to be handled to provide the service to the system. Okay. And in telecommunication system, it is the traffic to be handled, means how we are going to monitor the traffic, whether the traffic is less, whether the informations or the channels available to communicate between the subscribers are right or less. This determines the number of trunks to be provided, means how many calls are in progress at that moment. Say for example, if I'm going to communicate with 10 number of subscribers during 1 hour, how many calls are there, how many trunks are connected to the subscriber from one station to the other stations. Okay, that is what the meaning of this particular introduction. Where any industrial plants to be designed, definitely a decision has to be made in terms of size, in terms of subscribers, in terms of components. Okay. Along with that, in addition to this, how traffic is to be handled and how many trunks are needed to connect a call from one subscriber to the other subscriber between the stations, or it might be other stations. Okay, and this is a simple block diagram where we can have the components or the list of sub devices or devices which helps to communicate in between one subscriber end to the other subscriber end. This is the introduction part of a telecommunication traffic. Okay, next, what do you mean by trunk? Now look at here. In tele traffic engineering, trunk is used to describe any entity that will carry one call. Means at a time it carries only one call. One trunk in the sense what? One trunk is equivalent to one call. You can see the you can see the simple figure here, where at the left side of this slide there are multiple wires, multiple advice are connected to the trunk device, where only one wire is connected to the one call. Means one trunk helps to connect a call to the subscriber from one station to the other station. In spite of multiple wires here, multiple ends of the wires, only one wire is connecting directly to the call. Okay, only one trunk is nothing but what? One call. It may be an international call, or it may be a local call. The trunk, it might be what? International calls, or it might be a local calls. That all depends upon how the length of, whether they are communicating to the several thousands of kilometers, or it might be in terms of meters. Say for example, if it may be an international call, then definitely I am going to speak in terms of lengths of, or thousands of kilometers length, or it might be a trunk or the call with respect to the local, then only a several meters or several meters or few meters is required in the exchange or in the same telephone exchange. That is what the meaning of this particular trunk. And what is the meaning of trunking? The arrangement of trunks and as well as switches within a telephone exchange is called as trunking. Where now you can look out the figure at the right side of slide, where a telecom company is there here. Now with the help of trunk lines, they are connecting lines, or they are connecting calls to the different phone users or different subscribers through these devices from telephone company through trunk lines to the different subscribers, where the calls are going to be monitored by using these servers. A computer is there here with the help of different network lines. What they are doing, they are monitoring the different number of subscribes calls. Okay, or it might be what? It might be an international call, or it might be a local call, and that purely depends upon several kilometers and as well as the meters. Okay, this is what the meaning of trunking, where if you consider the definition of trunking, the arrangement of trunks and as well as switches within a telephone exchange or within a telephone network is called as trunking. Now you can see here, so we have switches here, different types of switches along with the lines. Without trunk lines or without trunk, you cannot pass any information from one company to the source company to the different number of subscribers. Okay, for that purpose an arrangement has to be done with respect to the trunk lines and as well as some switches. If I want to connect only one user who is located in some remote locations, so at that time what happens, definitely we need a switch, because I need to connect to a particular user. I'm not interested in some other users. I want to connect it for a particular user. So for that purpose, what we need circuit switches. Okay, so that is what the meaning of this particular trunking, where the arrangement of trunks and switches within a telephone exchange is called as what? Trunking. This is what a simple diagram we have considered here. Okay, where trunks and as well as switches plays very important role in a telephone exchange. That particular definition is called as what? Trunking. Okay, so for a time being, you consider that one trunk is equivalent to one call. Only one trunk and as well as one call. Okay, if I want to consider two trunks, then two calls are connected and two calls are in progress. Okay, that is what the meaning of this trunk. Now let us move towards at how traffic variations in minutes. Okay, see for example, here we are speaking about traffic variations. Okay, how the traffic variations are going to be considered in minutes. The figure 3.1 shows the average traffic in minutes. It shows the number of calls in progress on a large telecommunication system. Okay, now look at the figure here, where x-axis is nothing but time in minutes and y-axis is call in progress. If you consider 0 to 4 minutes, okay, 0 to 4 minutes, then the average number of calls are in progress in this fashion. Means here they are going to consider the number of calls varies in random manner as individual call begin and end. Okay, they are not considered in a day. They have considered only 4 minutes, and now they are going to plot a graph with how the number of calls are going to be in progress individually from a beginning to the end. Okay, some call may connect and at the same time some call may disconnect. So that is what the meaning of this particular traffic variations. Traffic is what? Some information is carrying that in that particular channel. Because of that, what happens? We call it as a traffic. So similarly, some call is progressed from 0 to 4 minutes. That is what, since we have considered only 0 to 4 minutes in the explanation, we call it as short term traffic variations. There is some variations, no, where x-axis is time in minutes and call in progress at the y-axis, and there is some variations, and that variation is what, random in nature. Okay, random in nature of an individual calls. Say for a minute, so many number of calls are connected, and the same time so many number of calls are disconnected or progress. And similarly for the second minute, again there are some calls. You can see the number of calls connected over there. And similarly the third hour, again so many number of calls are connected. And fourth hour, fourth minute, again there are some calls which are reduced when you compare with first minute, and as well as in between the first minute. Okay, that is what the meaning of this traffic variations. And traffic variations does not remains same from 0 to 24 hours. Okay, there will be a variations. Traffic doesn't remains constant, because number of members will get into the call, and sometimes the members when were not get into the call, and at that time what happens, the lines will be busy whenever the calls are in progress, and the lines will be open, and the lines will be kept free when the number of subscribers, if they are not connected a call to the other end of the subscribers. That is what the meaning of this traffic variations in a minute. They have considered only a minute, and according to that they have explained here. Okay, and similarly, if I'm go for traffic variations during a day, so figure 3.2, this figure 3.2, at the right side of the figure, traffic variations during a day, again they have considered time of the day at the x-axis and call in progress at the y-axis. And now the whole day, like 24 hours, they are going to consider, instead of minutes they are going for 24 hours in terms of hours. And now they are going to plot a graph with when with a estimation of busy hour. What is busy hour? See, in a day, in a earlier days, what happens, the calls, the people were connecting a calls or connecting to get to work from 5 a.m. and to 12 p.m. Okay, 5 a.m. They have started the work from 5 a.m. and it goes on increases, and at the busy hour like 10 to 12. Now your class has been started from 10 to 12, because most of the engineering colleges, most of the officials, they'll be using these platforms at this point of time, that is 10 to 11. At that time what happens, the lines were most of the time they were busy. That particular time is called as what, peak time or busy hour. After completion of 11 to 12 and so happens, then gradually the graph is going to be reduced, where the number of calls in progress is going to be reduced up to the end, up to the 12 p.m. Okay, so what up to the 12, right? This is what with respect to the am, and as well as with respect to the pm. Okay, how the calls are going to get busy at, okay, at the 24 hours, and how the progress of the calls they are going to be considered for a variations or traffic variations during a day. See, figure 3.2 shows the way in which the average traffic varies during the working day at a typical medium size telephone exchange or a transmission route. Okay, there are very few calls during the night. We know that there are very few calls during the night. At that time, definitely the lines will be free. Next, the number of calls rises as people go to the work. See, our as per schedule, our class will start from what? Scheduled from 10 to 5. Okay, 10 to 5 o'clock. Means the timetable is scheduled as per timetable. We have started work from 10 to 5. Now, at that time, during 10 a.m., definitely the calls will be busy. Okay, the number of calls rises as people go to the work and reaches a maximum by the middle of the morning. Okay, there will be a busy hour. It falls at the midday. Okay, during 1 o'clock and 2 o'clock or 2 to 3, people go to home from working days, and it has a further peak in the evening. Again, there will be a further peak at the evening and make people social calls. Okay, busy hour, what is the definition of busy hour? It is a period of 1 hour which corresponds to the peak traffic load in figure 3.2, like 3:10 a.m. to 11 a.m. is called as a busy hour because the lines were busy for all the time at that particular intervals. Okay, so busy hour is from 10 to 11 a.m. This is what this is what 10 to 11 is a busy hour if you consider a 24 hours in a day. Okay, next, the concept is the unit of traffic. Traffic intensity or simple traffic is defined as what? The average number of calls in progress. They are going to consider the single day, and now they are going to check how many calls how many calls or the average number of calls in progress at that particular day. If you consider the meaning of one day, if you consider the meaning of only 1 minute, so at that time, how the calls are in progress, how the channels are in progress, how the channel is in with traffic, and how many calls are in progress at that particular intervals of 1 minute. Okay, that says the unit of traffic. The unit of traffic is what? Erlong. Erlong, named after AK Erlong, the scientist name who find out the traffic, who find out the unit of traffic is what? Erlong, AK Erlong. So the name, that unit of traffic is kept as what? Erlong, ERLANG. Okay, on a group of trunk, the average number of calls in progress depends on both the number of calls which arrive at their durations. Okay, there were a group of trunks, we have a different group of trunks. Now if I want to calculate the average number of calls in progress, that directly depends on what? Both incoming and as well as outgoing at that particular durations. Okay, I'm not going to consider only the incoming calls at that moment. I'm going to consider both the calls. One is incoming call and as well as outgoing calls. Based on these two, I'm going to say the traffic, okay, variations or the traffic conditions of that particular module or any systems. That is what the meaning of this particular point, where on a group of trunks there may be a chance to have incoming calls and as well as outgoing calls. Both they have considered to find out or to calculate the value of traffic. Okay, where the traffic intensity or simple traffic is defined as what? Average number of calls in progress at that moment. If I am considered today at 11 a.m. to 12 p.m., if I want how many calls are in progress, so now they are going to divide 11 a.m. to 12 p.m. into the number of intervals, and now they are going to count how many calls are connected at that particular time. So based on that, they'll provide a, okay, they are going to provide a numbers. Say for example, 1000 number of subscribers are connected, where the average number of subscribers at that moment from 11 a.m. to 12 p.m. Okay, 12 p.m. is 100 number of 1000 number of subscribers will be connected at that moment, and now that particular time is called as what? Busy hour. Okay, where the 1000 number of subscribers are called as what? Okay, consists of 1000 number of subscriber consists of both incoming and as well as outgoing calls. Okay, outgoing and as well as incoming calls. And if I want to calculate the values, then the unit is what? Unit of traffic is what? Erlang. Who is Erlang? Is the scientist names where he find out the unit of that traffic. Okay, he has suggested some information related to that, so they kept the name as Erlang. So next concept is holding time. What is holding time? If I want to, for example, if I want to hold this call from 10 a.m. to 11 a.m. Okay. Anyhow, I'm consider I was I am con I am considered this particular lecture from what 10 a.m. to 11 a.m. If I hold 10 a.m. to 11 a.m., that particular time is called as what? Holding time, because I am conveying the information through this app with respect to 10 a.m. to 11 a.m. That particular time is called as what? Duration of a call. And duration of call is often called as what? Holding time. Okay, where it holds trunk for that specific time. What is that specific time? 10 a.m. to 11 a.m. is called as what? Trunk time. Or it is called as what? A duration of the call is hold for some time, which is nothing but what? 10 a.m. to 11 a.m. And that specific time is considered as what? Holding time. That is what the meaning of this holding time. Now look at the example which shows 1 hour of traffic can result from one trunk being busy all the time, for each of the two trunks being busy for off time, or from each of the three trunks being busy for 1/3 of the time, as shown in figure A, B, C. Look at the figure 3.3. They have considered an example of 1 hour of traffic carried on three trunks. Look at there, 1 hour, okay, and 1 hour where the three trunks are considered. The first trunk is blank. Blank represents what? It is free. Okay. The second trunk in the figure number A is shaded with gray coat, where this indicates the trunk is busy. Okay. Similarly, or some traffic is there. And at the same time, for the third trunk, again we have a blank where it indicates the trunk is free. Okay, so on an average, two trunks are available free, where one trunk is busy at that moment. Okay, and for in the second figure, again 1 and 3 figures, 1 and 3 trunks are busy, where little bit busy, and the second trunk is free to communicate. And similarly, for the third case, 1/3 of all the three trunks are busy, and 1/3 of all the trunks are busy along with the free conditions. Some part of the trunks are free and some part of the trunks are busy. So these are some conditions, and as well as these are some examples how 1 hour of traffic carried on three trunks. Okay, and you can see the notations below the figure, where blank represents free trunk and shaded gray is denoted as busy status. Okay, where the traffic is represented as what? 1 hour. That is what? 1E. Okay, 1 hour. In North America, traffic expressed in terms of hundreds of calls seconds per hour, that is represented as CCS. Okay, CCS in North America, what the traffic, how they are going to express the traffic? They are expressed in terms of hundreds of calls per hour or hundreds of call seconds per hour, that is represented as CCS. And C in the sense what? 100. C is what? Centum. Centum is nothing but what? 100. So they have used CCS. Okay, in 1 hour, if I considered 1 hour, that is equivalent to 3600 seconds. But if you express in terms of 1 hour in North America, they have considered 36 CCS. Okay, 36 CCS, where C stands for what? Centum. Centum is what? 100. 3600 calls per second. All calls seconds. Okay, so 1 hour is equal to 36 CCS, according to which? North America. Okay, again the telecommunication specifications or network, we have two things specified in two terms. One according to the specifications formed by British, and one more is what? North America. According to the North America, they have considered is 1 hour is equal to 36 CCS. Okay, from the definition of the hour, that the traffic carried by the group of trunk is given by what? A is equal to C into H divided by T, where A is what? A represents traffic in hour-longs. If I want to calculate traffic in hour-longs, so we have formula A is equal to C into H divided by T, where A is nothing but traffic in progress or traffic in hour-longs progress, and C is equal to average number of calls arrivals during T or during time. and that capital T is called as what? 60 seconds. Okay, we have 60 seconds. H is equal to what? Average call holding time. H means average call holding time. Say for example, if T is equal to H, if the time or average number of call arrivals during time T is equivalent to H, assume if T is equal to H, then definitely what happens? A is equal to C. A is equal to C. Okay. Thus, number of calls arriving during a period equal to the mean duration of the calls. If T is equal to H, then definitely traffic in Erlang's is equivalent to average number of calls arrival during that mean duration of time. E is equivalent. Okay. Since a single trunk cannot carry more than one call. As I said that one trunk is equal to what? One call. It cannot carry more than one call. Okay. Based on that definition, based upon that assumption and as well as the truth, what happens? The value of A is always less than that or equal to 1. Okay. If A increases or greater than or equal to 1, definitely what happens? The operation is not going to carry. Now, if A is less than or equal to 1, because of what? Trunk will carry only 1. The value of 1. It won't carry more than 2 calls, more than 1 calls. Okay. So A is less than or equal to 1. Now, if this is right, then the traffic is a fraction of an error long equal to the average proportion of time for which the trunk is busy. Okay, this is called the occupancy of the trunk. Say for example, if A is less than or equal to 1, so because of that content or instance, we call it as what? Occupancy of the trunk. Now what I am connected, the call is connected from host to all the subscribers in the sense what? You people are looking at the subscribers who are there in the some remote locations, and now this particular time from 10 a.m. to 11 a.m. I'm going to call it as what? Busy hour, and this particular condition is called as what? Occupancy of the trunk. After 11, I don't know. The call definitely it is going to disconnect. Now that particular time I'm not going to say it as an occupancy. It is a disoccupancy of the trunk. But here what we have, because of this schedule, when A is less than or equal to 1, because of that instant what happens? The call is get connected from host to the different subscribers who are there located in some different locations, and that particular operation we have is called occupancy of the trunk. Okay. Now look at some problems, very simple problems we have, and in the examination they'll ask for 5 marks. See, at certain exchange, a total of 5,000 calls are originated during the busy hour. Okay, say for example 10 to 11 is called as busy hour, where in 10 to 11 in the busy hour 5,000 calls are originated. Okay, if the average holding time of call is 21 minutes, on an average each call will take 21 minutes to hold a particular call. Some may take like what? 2 hours or 1 full hour to talk with different number of subscribers. Sometimes some call may connect only 30 minutes, some call may connect 20 minutes, but on an average if you take at busy hour, one busy hour, so at that time for 5,000 calls are originated, and each of the call on an average they are going to have holding time of 21 minutes. Okay, now calculate the flow of traffic during this period. Now we need to find out the traffic. Now we need to find out the traffic in terms of Erlang. Okay, now we have the formula, that is A is equal to C into H divided by T, where A is traffic in Erlongs. Okay, and H is holding time, T is average number of calls in that hour. Okay, now we need to find out the traffic in Erlongs, where A is equal to C into H divided by T, where C is what? Total of 5,000 calls are originated during busy hours. Now you can substitute the values of C, that is 5,000 into so holding time. Now find out this holding time. How much? 21. It's not 2.5. that is 21 divided by 60, that is equal to 208.3. Okay. So similarly, for the next problem, on an average, during the busy hour, a company makes 120 outgoing calls of average duration of 2 minutes. It receives 200 incoming calls of average duration 3 minutes. Find outgoing traffic, incoming traffic, and as well as total traffic. As we know that outgoing traffic, that is equal to outgoing calls into H divided by T, where T always remains 60. Okay. Outgoing calls, what they have specified here, 120 outgoing calls on an average, what, 2 minutes they have taken. So 120 into 2 divided by 60, that is equal to 4 air longs. When they come across incoming calls, at that time traffic, okay, in terms of incoming calls, that is equal to incoming calls into holding time divided by T, where incoming calls are 200 into average of 3 minutes, that is into 3 divided by 60, that is equal to 10 air longs. So total, if I want the total traffic included outgoing and as well as incoming, so at that time you can add both traffic related outgoing calls and as well as incoming calls, that is 14 air longs. Okay, this is what, how we need to calculate the traffic in terms of air longs. Now we'll move towards the next concept, that is congestion. What do you mean by congestion? The situation where all the trunks in a group of trunks are busy, so it can accept no further calls. This state is known as congestion. Say for example, I'm using a WebEx meeting or Cisco WebEx software online platform to connect a call from host to subscribers. Say for example, only the limited number of subscribers, if I am going to consider only 42 number of subscribers are there, then I can connect a call to the subscriber and I can talk. Suppose if more than 42, already 42 subscribers were present in the meeting, after that if few more subscribers, if they want to attend a meeting, then the trunk will not allow us to connect from host to the subscribers. Okay, that is what the meaning of congestion. No further acceptance of further calls. Okay, some situations will be come where no future calls will get connected to the existing calls, where the trunks are busy. Because of the trunks and the group of trunks are busy, because of that what happens, this state is called as what, congestion. Again we speak in terms of two things, one in terms of message switching systems, and other part of that is circuit switching systems. In case of message switching system, call that arrive during congestion wait in a queue until an outgoing trunk becomes free. Thus, they are called as what? Delayed but not lost. Such systems are called queuing or delay systems. So, in case of message switching systems, what happens? The 43rd call of or 43rd call will wait in the congestion time, and then it, once the call or once any of the 42 members, if they leave the meeting, and then the 43rd call will enter into the room. Okay, the call will not get lost. Only what happens, he should wait until and unless 40-second or 40-second call has to depart from that area or the room. If he becomes free, if 40-second or 40th or 40 out of 40-second, if any one of the call becomes free, then at that time what happens, other call will enter into the room, where such systems are called as what, queuing system, because he is waiting for to connect a call. Okay, he is not going to, the call is not going to get lost, or the call is not going to lost at that moment. In case of what? In case of message switching systems. But when you consider circuit switching system, this is not possible, where if all attempts to make a call over a congested groups are unsuccessful, then definitely what happens, such systems are called as lost call systems. They are not going to call it as queuing systems. When all 42 members are connected to a group, and it will not allow the 43rd or 44th member to connect into that particular group. In case of where? In case of switching systems, in case of circuit switching systems. Okay, that particular operation is called as what? Lost call systems. Okay, in lost call systems, traffic carried is equal to traffic offered minus traffic lost. The proportion of calls that is lost or delayed due to congestion is measure of service provided. It is called as what? Grade of service. We need to measure the content of how many calls are in the queue state and how many calls are in the delayed state, or how many calls they have lost during that particular time. This we need to provide in terms of what? Grade of service, which is designated by B. Okay, for lost local call system, the grade of service B can be defined as what? B is equal to number of calls lost divided by number of calls offered. Hence, B can also be written where B is represented by what? Grade of service. It can also be called as traffic lost divided by traffic offered. Okay, why we are doing this? Because we need to check how many calls are in the queue or the delay system and how many calls are lost call systems. So if I want to find out this, I need to measure with respect to what? Grade of service. Okay, and the definition of grade of service is what? Number of calls lost divided by number of calls offered. Hence, I can also be called it as what? Traffic lost divided by traffic offered. Okay, thus, then what will be the condition of grade of service? If the value of B increases, definitely what happens? The service is very weak. The worse is the service again given, because the grade of service is normally specified for the traffic at the busy hour, and other times it is much better, because if you increase the value of grade of service, that shows that there are many number of calls are waiting to connect for that particular event, or sometimes most of the calls they are not going to get connect to that particular event. So, and this is going to be done at the only the busy hour, and at other times it might be much better. Okay, say for example, thus if traffic A Airlongs is offered to a group of trunks having grade of service B, then traffic lost is what? A into B. Understand that? A into B. Traffic lost is what? A into B. And the traffic carried is what? A minus A into B, where if you take common A, then A into 1 minus B Airlongs. Okay, now look at this. Again, again a problem statement we have. During the busy hour, 1200 calls were offered to a group of trunks and 6 calls were lost. The average call duration was 3 minutes. Find traffic offered, traffic carried, traffic lost, grade of services, and total duration of periods of congestions. Now look into the solution part. If I want to calculate traffic carried, I have an equation given by the Erlong, where A is equal to C into H divided by T. That is, traffic carried is given by what? Total 1200 calls were offered. So 1200 into 3 divided by 60, that is equal to 60 Erlongs. T remains same. Don't change the value of T. That is, T is equal to 60 seconds. And C is equal to 1200, and the holding time what they have given is 3 minutes. Okay, even to calculate the value of traffic offered, A is equal to C into H divided by T, we have that is equal to 1194 into 3 divided by 60. Why it is 1194? Because in the problem statement he has given 6 calls were lost. Out of 1200, if 6 calls were lost, then we have up to 1194, and average duration of holding time is what? 3 minutes. So 1194 into 3 divided by 60 is equal to 59.7 Erlong. Okay, and next for the third case, traffic lost. If I want to find out traffic lost, again I have A is equal to C into H divided by T, that is equal to how many calls were lost? 6 lost. 6 calls were lost. So the value of C remains 6 now. C into 3 divided by 60, that is equal to 0.3 Erlongs. Now, the fourth case is what? We need to find out the grade of service, that is B. B is equal to, we have the equation, traffic lost divided by traffic offered, that is equal to, we have the value of traffic lost, that is 0.3 divided by traffic hour offered, that is 59.7, that is equal to 0.005. Now, for the last case, if I want to find out total duration of periods of congestion, now the total duration of periods of congestion can be calculated by what? B into the total in terms of seconds. That total time in terms of seconds, that is 3600. Okay, that is 0.005 into 3600. That is equal to how much? 18 seconds. Now they have considered in terms of seconds, they have considered instead of minutes, they have expressed this in terms of seconds. That will be 18 seconds. This is what a problem statements in the examination they may ask with change in some given data. Okay. And now the next concept is traffic measurement, where it means that measuring of busy hour traffic is necessary and regularly operating company needs to measure and keep the records. Okay, so like if I want to calculate the traffic measure or traffic during busy hour, say for example 10 to 11 is a busy hour, we need to divide in terms of intervals. Okay, and then I need to calculate how many calls were there at that moment. I need to keep the records. Today I have divided and total 5,000 number of users were connected during 10 to 11. So similarly tomorrow again I am going to do that, and I'm going to find how many calls were there during busy hour. So that is what on and average we need to write by looking at that. Okay, under busy hour on and average 5,000 to 6,000 number of users may connect at that moment, and we need to keep the record. That is what they are saying. And the next, by definition, measuring the traffic carried amounts to counting calls in progress at regular intervals during the busy hour and averaging the results. So for 10 days we need to calculate the calls at busy hour and we need to keep the record. Okay, in the past earlier days the engineers counted the plugs inserted in a manual switchboard or the number of selector of normal in a automatic exchange by peg count or switch count method. Later automatic traffic records were used in automatic exchange. Earlier there was a manual switching and number of calls will be measured based on the switching board, based on the manual switchboard. Okay, and now later on they have used peg count or switch count to measure the traffic, of the call, and along with that later automatic traffic records were existed, and were used in automatic exchange to record the calls. But today what we are using in modern digital switching systems, in modern a stored control program we have, the central processors we have, that will generate the calls, and according to the setups they are going to provide a record at how many calls were there at the busy hours. And whatever I'm saying, that is past, that is related to the 10 years back, like busy hour is 10 to 11. Now it is not possible. Okay, in modern switching systems it is different. The busy hour it may be within mid of the day. Okay, the progress, when the calls are in progress, that particular content we can call it as busy hours. And with respect to that, again we have one problem statement here. Observations were made of the number of busy lines in a group of junctions at intervals of 5 minutes during the busy hour. The results obtained were 11, 13, 8, 10, 12, 14, 7, 15, 17, 16, 12. Okay, and even 9 is there, it is misprinted. Solution: it is therefore estimated that the traffic carried in Erlang's was all the results obtained by then in the intervals of time we need to add and divided by 12. How many intervals we have there? 12 intervals, total 12 intervals, that is 11, 13, 8, 10, 14, 12, 7, 9, 15, 1, 16, 12 divided by 12. So if you add and divide it by 12, so you will get the value of 12 Erlangs. That is what the traffic you can also calculate in terms of Erlangs to measure the traffic in the busy hours. Okay, and how olden days and as well as now modern systems, purely the modern systems, they are using some instructions and as well as controlled programs. But earlier it was not like that. Earlier a manual switchboard were used and a peg count they used and automatic exchange records to store records and all they are using to measure the traffic conditions. Okay, that is what the meaning of this traffic measurements. Okay, so is there any doubts? Is there any doubts?
No, sir.
Hmm? Any doubts? I'm not hearing you. It's not audible for me. No doubt? Is there any doubts?
No, sir.
Okay then. Then for next, for tomorrow's class, I'm going to deliver mathematical model, last call systems, and as well as queuing systems. Okay. So only 3 to 4 class is required to complete this third module, and that will be help for your examination point of view. Okay. Anyhow, I have taken a class for your fourth module, and only uh, some 3 to 4 portions are left in the fifth module. I'm going to do it. Okay. Shall I end this?